Hi, I'm Paul Wheels, founder of IoT North. Great to have you here. We've got a great show today with Vibhu Bithar and Devang talking us through computer vision eye-to-eye ideation to inception, making the journey easy. So I'll just bring the guys online now. Hi guys, how are you doing?
Hey Paul, how are you doing?
I'm good.
Hey, I'm doing
Good to see
good
everybody
too.
saying. Good to see everybody saying hello this evening. Great to have you online. If you have any questions, please do ask throughout the show. I'm sure Vibhu and Devang would happily answer any questions that you have. Guys, Vibhu, we've talked about the Edge Dev Cloud a few times with a couple of the projects I've worked on in the past with Intel. Really looking forward to this talk. I'm going to be quite short and sweet and just hand it over to you to take the reins.
Perfect. Thank you. Thanks, Paul. So yes, this is my, you can say it's my personal journey to have an idea and then make it available. So I'll start sharing my screen and to walk you through a slide which is more informative, and you guys can look at it. Let me know when, Paul, is it live now?
Yep, it's live.
Perfect. So let's go
I
through it.
Actually, Vibhu, I think you're going to have to swap the screens on which one you're sharing because you're showing your notes screen rather than the presentation screen.
Okay, the demo gods are talking now. So let's go. Okay, so now is it better?
Yeah, it is. Yeah, let me bring it back
Okay,
in for you. There you go.
perfect. Okay, guys, so let me talk about my own use case, how I thought this technology can make a difference in everybody's life. And there was some news about people getting swept into the sea. How do search and rescue operations happen? And said, you know, computer vision can help there, but it's always has a place in these kind of situations. And my use case was if you are on a beach and playing in the water, how can somebody or a system can watch if somebody is in the safe zone or not in safe zone, so that the search and rescue teams or the lifeguards can react quickly. So what do I need for all that, right? I need an edge compute instance because I can't lug around my CPU to or like the whole machine to the beach to have this system. It has to be rugged, small, and basically crowdsourced, so everybody can take benefit of using these small edge systems to do uh, um, um, to do the AI inferencing, right? That's number one. A source of video, it could be a CCTV camera, it could be a drone or an action cam, something that can get I can get the feed from. A setup on my edge device that is not very hard to do. One click would be best, and how I can then quickly start detecting things, and then setting it up in a way that I don't need to have a machine like a monitor to be carried around all the time. It should just start up, start detecting, and inform you if there is some issue. And the most important thing, a model that can detect humans in a zone or outer zone when when they are seen from a drone's point of view, right? Because things look different as the point of view change. Well, the good news is I have most of the components. Some of them are thanks to ADlink for building ViziAI Dev Kit, which is awesome small compute that has Intel Mobilenet inside it that can accelerate your inference. So it's all built in, ready to go. Drone or action camera, whatever that can send an RTSP feed to it or other ways. That's secondary point, that how do you get the feed inside. But in the drone that I have and the action camera I have, both have RTSP feeds coming out of them, so I can absorb them. uh, then how do you set up? And that I will talk a little bit more. The setup part could become daunting because there's so many components getting together. But for certain aspects of it, Intel has is going to help developers to set the whole cloud to edge pipeline using Edge Software Hub, which is our place where you can install set up your edge device as well as your cloud system, with just literally one click. You'd go there, register, download the setup file, and it sets up everything. And I'll show you how easy it is. Then few more things that I have to do. Those are specific to the device, so maybe specific to my use case. Maybe if you can carry a monitor, then you don't need these kind of things. So I'll talk about that. What did I do to make it for my use case? And the last part, how do you train your model in the cloud so that I'm detecting humans? You might want to detect sharks or something else, depending on your use case. So what are the utilities Intel is providing to help you with that? So to start with, our edge compute instance is readily available on different websites, and it's very reasonably priced to do that kind of inferencing. From the utility perspective, we developed three main utilities, right? And I'll go deep into each one of them. And these QR codes, you can scan them on your screen, and then you can go directly to the link to take advantage of one or all together. The bottom link on the left-hand side bottom is your link for the whole block that stitches together, optimize, benchmark, and deploy all the things together. And these are can be modular, you can use individually or the whole thing at the same time. So let's talk about why even these utilities exist, right? If you talk about cloud developer world or a developer ecosystem, there's a user who has an use case, and in between there are AI, ML frameworks. If you are using AWS, then you are using Greengrass to deploy your code from cloud to edge in Lambda. Some business logic that you have to write, and some cloud setup to make it happen. Now, cloud developers know these things very well. There are some options to choose between Cafe, MXNet, or TensorFlow, or any other framework they prefer. But the whole effort goes into writing the business logic, right? That's the biggest circle in there. But as we introduced OpenVINO, we gave so much power to the people. They can use so many different frameworks. The ones they existingly use, there are others that are available and are going to be available to them. Then there is Opencv, NumPy, and you can use RTSP feed, camera feeds, many different Intel hardware from CPU to integrated GPU on Intel core processors to specialized hardware like HDDL, which is array of Movidius VPUs to take advantage of the parallel inferencing on those cards. They can all be used, but that makes the ecosystem a little complicated. But then that's where our starting point was. Like, we don't want to make it complicated. All these things are just one-time setup, but it has to consistently work so the user can focus on their focus area, which is the business case. But in my case, similar thing happened. My focus should be, how do I detect humans, not how do I install the system and make sure it runs every single time. So I worked with the Edge Software Hub team inside Intel and helped them build this deployment process that makes life easy. That is the place where you actually go, you download the part, you do a one click on the use case, and it will not only set your system up with the right libraries that the computer, so Opencv needs, also the right libraries for OpenVINO, which is doing the inferencing using the Intel hardware, accelerating on it. Also, it goes a step further. It sets up your cloud. It sets up your Greengrass thing. Also sets up your the S3 bucket and whatever you need to deploy a Lambda, a simple basic Lambda, which does object detection or image classification, sets it up in the cloud and deploys it to the edge, and also starts sending messages back. So your whole pipeline is done. Now you have to go back into your Lambda and just write the business logic you want to get deployed again. And with just one more click, it will get deployed again. So that's the benefit of Edge Software Hubs, this RI. So let's go through it very quickly. I will be going.
Sorry, Vibhu, we've got a quick question here from Joe. On the training side, did you have trouble due to light reflection, waves, anything else thrown off this model?
Well, We did find some issues. We are still fine-tuning the model, but me or Devang, who is going to present how he trained his model, are no data scientists. We just use off-the-shelf products and did the training in SageMaker, and we are still learning how it goes. But one thing I've seen is model is as good as the data you provided. And in our case, I was not finding publicly available data on swimmers in the ocean. So I went out to the ocean and took videos from different heights, different angles using my drone and gave it to Devang to train. And we are seeing improvements as we show our data to the model. Model learns and then reflects back in detections, and you'll see it very quickly.
Okay. And did he say he's also asking, wondering if camera quality had to be carefully considered with the cost?
That's very true. And it all depends on your use case. I would say we are going for the art of possible. What all I think like these days drones are readily available. People fly them. Even amateurs can participate in search and rescue missions. So from my perspective, this use case was not bounded by the cost of the equipment, but more of what you can do with your equipment. But when this will be taken into the real world, yes, those are the real things that you have to consider.
Brilliant. Joe says thank you. We've also got another question here. What frames per second are you achieving in object detection with vanilla Mobilenet SSD?
Yes, so it depends on the feed quality, the stream quality, and the speed of how you're presenting. From a drone on an RTSP feed, I'm getting up to 11 frames per second. This has no hyperparameter adjusted, nothing. It's vanilla, just my objects. On my camera, I have gone up to 23 to 24. Like I have a GoPro that can do a RTSP feed on 480p. I can go up to 23, 24 frames per second.
Yeah. Brilliant. We'll let you carry on.
Okay. Oh, perfect. These are awesome questions. Please keep asking. I love these things because I learn from these questions too. So going quickly into the demo, basically what I'm trying to show here is, if I can play this video, is how you can, okay, it says the codec unavailable. Well, I think I have to skip the video part of it, but just to showcase like what it will entail is, or maybe I will go a little bit off. Okay. So I think I cannot play the video here, but what I was trying to show was how easy it is to install this using Edge Software Hub. It goes through different steps of how you can go to this website that's open in front of you, register, and just set up the config file and wait. It will install everything that you need to run Cloud to Edge inference. I'll get back to it if I get more time to showcase this. But let's move on to once I was able to install this. What I did was this is how I work, right? So I took the Lambda function from this install and went directly into this thing, this part. Okay, so this is our the video. This is the end product of the demo that we were able to build so far, and thanks to Devang for actually training the model. And you can see that I put my drone stationary at the cloud, and it can detect humans on the beach. Quality can be improved, and detections can be improved, but right now the focus was to see how end-to-end pipeline works. So how did I make it happen, right? So what did I do to my ViziAI dev kit to achieve this? So first of all, I need to communicate back to the cloud. So I have to add two dongles. Basically, I added two Wi-Fi USB sticks to my ViziAI. One is used to set up what you call a hotspot on my ViziAI box, and the other one is the Wi-Fi backhaul. So I connect it to my phone teeth ring, or if I am at home, I connect it to my normal Wi-Fi system, and that can transmit data back to the cloud.
Sorry, Vibhu, we've got another question come through. Did you get that throughput on VPU in brackets NCS?
Oh, the Mobilenet strike, right?
Yeah. So
Yes, that is correct.
Yeah. Great.
Yeah, because ViziAI Kit doesn't have a powerful CPU, hence all the inferencing that is happening is purely happening on the VPU. And the benefit of that is, that's a very awesome question. The benefit of that is my CPU is not so busy and it can handle the frames, running the NGIX server to receive the frames and pre-process them, right? The Python code is running. So it's not like my system is not dying. All the inferencing is offloaded to my VPU.
Great.
Okay. So as I was talking about it, so after the two Wi-Fi dongles are added, I installed the RTMP server and using enable the RTMP endpoint on my the NGX thing, and that's it. That's all I need to get the feed from and pass it as a frame by frame to my OpenVINO code. Basically, the sample lambda function that you install with Edge Software Hub. I just took that Python file as is and added few more things. And I'll show you what did I do to that file in a second. As soon as my drone goes in the air, I do live streaming. It has say which endpoint you want to use. I gave it to the Wi-Fi hotspot as I told you upfront that I gave it my Wi-Fi hotspot's address, and it starts sending the feed. So let's talk about the code blocks. So when you do Edge Software Hub install of these Python, the object detection Python code, which run asynchronously on your VPU, which means it can take, it doesn't depend on it doesn't take the feed coming in a frame and then processes it. It creates a buffer of frames, passes it to the VPU and gets it processed. So it can do parallel processing depending on the number of cores you have inside the VPU and things like that. So that's how the code looks like. The original code has some import system, get model function to take whatever model you are supplying to it, because you can do SSD, Mobilenet, many different ones. Set the plugin and the configs, what parameters you want to pass, how many threads you want to spin up, and things like that. And then print raw result, draw detection, and then the asynchronous code that takes frame by frame and does processing. So that was the original code that came with the system. I just added two more things. I added a function for checking the object location. Basically, if I draw an imaginary line in the center of the frame, and my bounding box, let's say X min of the bounding box is above that line. It's a crude way of doing it, but I'm still developing as I speak. Or I can do centroid based. There are many ways to fine tune it, but if the bounding box is above that line, I count it as safe zone, unsafe zone, and something below is safe zone. And all I'm detecting is human, so I don't have to worry about different objects. And I have to add one more function which came out of necessity, that RTSP feeds as they start, Opencv might get empty frames, or if it drops, then it gets an empty frame. So I have to keep checking whether I'm first connected and I'm getting a proper frame or not. It has to have some data in it, and then rest of the function remains same. So just by adding these two, this is my business logic. As I spoke earlier, I don't have to worry about setting up the pipeline or writing the code for asynchronous inferencing. No, I don't have to worry about that. I just bring in my feed, write my business logic. That's all. And then the crucial part of it. So this makes the whole system up and running. So from like a drone or from anywhere, I can get the subsystem up and running. But I think I need to.
You may need to close Teams.
Yeah. Otherwise, how do I quit it? Yeah. So for time being, it will be quiet. Okay, so now we have this OpenVINO system running and inferencing on the edge. How do I take it to the next level? That is train a model and then deploy it onto the edge. That's the next piece that we have to solve. So for that, I will have multiple utilities that I spoke about earlier, right? So what is my utility? So my utility is, first one is SageMaker is the environment that I've seen many developers use. It could be any other one, but OpenVINO inside SageMaker is what we enabled with our OpenVINO utility. Basically, what it does is when you open a SageMaker and clone our Git repo, it will, once you start executing the cells, it will download the OpenVINO Docker, full-blown developer Docker, which comes with optimizers and benchmarking tools and everything into your SageMaker notebook. And when you tell it that this is my model that I want to fine tune, convert, basically, first step in OpenVINO is converting a model. And then it will ask you the URL, download it, convert it. All the models that we support and their input shapes, for if it's an object detection model, or everything is part of the everything is already part of the Git repo. So you can just go through it and use it. And how to use it is part of the block that I showed in the beginning. Then if we look at the next stage, and then what will it ask you? It will ask you for what's your S3 bucket where you want to store the converted model. The benefit of that, this step, is that once you convert a model from any framework that we support into OpenVINO format, your code doesn't change. It just uses the OpenVINO as your inference engine, OpenVINO inference engine, and takes that converted model and runs it. So let's say in future you want to try YOLO or rather than SSD, and you want to try it in PyTorch. Yeah, you just convert it, and then you can continue to use the same code that you wrote. So you don't have to write it as per the different frameworks that you want to use. Another utility that we built alongside is that once you convert a model, how do you know how good it is, right? So we have this sandbox environment in the cloud where multiple Intel hardware are available to run inference on. So it goes from all the way from neural compute stack to the Xeon processor. So you can say that here is my model, converted model. I want to see the performance on all of these hardware, and it will give you a table. All it will ask you when you launch this the notebook in DevCloud, which is the sandbox environment for Intel, DevCloud for Edge, is your AWS credentials. So as to know which bucket your model is located, it will download and do a tabular way of showing you that these many frames per second on NCS versus Xeon, and then you can decide what your use case is. Okay, now I will hand it over to Devang to talk about an end-to-end fine-tuning process.
Thanks, Vibhu. So hey everyone. So now I'll be quickly taking you through the whole fine-tuning process I undertook to detect swimmers in the ocean. And as Vibhu mentioned before, I'm no data scientist, so this was only mainly for to kind of get the model working itself. And then of course it's still work in progress, so we'll still be fine-tuning it more. So the first step itself was to gather the images of swimmers swimming in the ocean and other people on the beach. And luckily, Intel had a small database where there were some available datasets that I could use. That's only for internal employees. And I used a few drone videos of beaches and split them up into frames and annotated them by labeling swimmers using a computer vision annotation tool. And in my case, I use CVAT, but there are many more annotation tools out there. And that all depends on person to person. So next, after I was done annotating, I exported the annotations as TF records and zipped up the TF record in PB text and placed it in an S3 bucket, as you can see in step 2 over there. And once I had my data in the S3 bucket, I launched a SageMaker instance. Now, our team has created a fine-tuning Jupyter notebook, and hopefully you should be able to get your hands on this very, very soon, that fine-tunes TensorFlow object detection models. So I went ahead and took this notebook and put it in my SageMaker instance. Now, the notebook had a few different sections to perform fine-tuning using my data. So the first section itself was the notebook downloaded my data into SageMaker from the S3 bucket. And once it was downloaded, it split the data 90 to 10 into training and testing data. And after I split the data, the notebook downloaded the no, after I split the data, I selected the model that I wanted to use. Now in this scenario, I used the SSD Mobilenet V2 model. And after I selected the model, the notebook downloaded the TF object detection API and the pre-trained model that I selected. After the object detection API and the pre-trained model was downloaded, I was able to make some edits to the pipeline.config file. Now, in this, I was able to make some changes to the batch size, the number of steps, and the learning rate. And after all this was done, I completed the training process where I trained the model and exported the model back into my SageMaker environment. And the next step after this was to convert this model to OpenVINO IR, like Vibhu mentioned before. And thankfully, this notebook had the capability that Vibhu discussed, which was using that ovutils.py, which is that script that we have, the Python script that downloads the OpenVINO Docker image into SageMaker, and then uses the model optimizer that OpenVINO has and converts my model to OpenVINO IR. So that final cell in that notebook was just to take my model and convert it to OpenVINO IR, and then takes the converted model and places it in the S3 bucket. So now that I had my model in the IR format, I had the option to choose which hardware is best for my model. And this step is typically optional, but I always do it so that I know exactly which hardware is best for my model and I can run some benchmarking on it. So I head over to Intel Dev Cloud for the edge, and I ran the benchmarking on my model through that sample notebook that we had that Vibhu presented earlier. And finally, now I know which hardware is best for my model, and I ran the benchmarking. Now that this model can be inserted into the AWS Cloud to Edge pipeline, which you can get from Intel Edge Software Hub, where I'm able to deploy my model on to edge devices like ADlink's ViziAI Dev Kit. That's pretty much it.
Awesome, guys. So yeah, I think thanks, Devang. Thanks a lot for doing this. And I intentionally gave Devang this thing because when we were building this, I have ideas. We build it, everything. As I saw as a developer, the challenges for me. But I said, what about a person who has participated but not built things, but is very much excited about it. Like he also has ideas that he want to implement. So I said, go crazy with this pipeline. I want to see everywhere you don't succeed is where I need to improve. And that's our mantra, right? Like to make sure we don't make AI, ML, ideation to inception process easy, but we make it simpler and so that you don't have to worry about installations and things like that. All you worry about is uh, think about your idea and what you need to, what's the business logic behind it, and that's it. How powerful the inferencing machine is, you don't have to cater to at the upfront, because even a dev kit is so powerful that on a separate note, I was discussing this in a search and rescue group within Facebook, and they use an app. What that app does is it looks at the pixel. So when you say I want to find this person or I want to find this object, you create a color palette of that object. You have to have a picture of it first of all. So then based on the different shades available in the pixels of that object, then it scans every image offline to basically detect if it finds. Now if there is noise in the picture or if it's low light, then you might find different colors coming in the frame. Another problem is trained search and rescue operator takes 3 minutes or 2.5 minutes per frame to look for object. Now I'm saying maybe this is not the final product, this is not everything, you still need humans to closely look at it, but this can be augmenting their capabilities so that live I can analyze my video on the ground. And if I find it saves so much time from search and rescue operations to happen in like hours to cut down to minutes, if it's trained pretty well. And that's why we focused on, okay, I don't want to just detect the objects that I can already detect with their model. What if I want to detect something specific? How would I go about it? And that's why we feel that maybe this is not the end product, but this is the starting point where people can take what they want out of a model and then use the pipeline to enable it. So I'll pause here. I'm pretty excited about this project, but your feedback and your comments would help us to make it even better. And when you try it and use it in your in real life projects, I'll be really happy to hear more about it.
Awesome. Thanks, Vibhu. Does anybody have any questions? Just put them into the comments on whichever platform you're on. Sorry, we've had some technical issues with LinkedIn today, but hopefully drove everybody to the YouTube channel. But yeah, if you have any questions, please do put them in the comments. Vibhu, you were telling me a story when we were emailing the other day about a surfer that spoke to you about that project.
Oh yes, thanks you bring it up. So I was recording my demo. I was testing it in the real world, which is ocean, and this the surfer dude comes up to me and is like, "What are you doing?" I'm like, "No, I'm just doing." And I was like, "How detailed should I go into technology of what I'm doing versus explain him?" So I said, my idea is that I want to detect people in the ocean, safe zone and not safe zone. So he's like, okay. Then he's like, okay, can I see it? I'm like, sure. And I'm like, why? So why are you so interested in it? He's like, I don't know, it's coincidence or what. Yesterday, and the waves at Santa Cruz Beach are kind of unpredictable near the pier. So he got like picked up by one of the waves and thrown slammed hard onto the ocean floor. Now it's a shallow floor, so it's not too deep. But when he fell on the ground, he said, I was for a fraction of a second unconscious. It knocked him out. And also there was a riptide going, which is pulling him back into the ocean rather than pushing him towards the shore. And he said, luckily and there were no lifeguards on duty at that point. And even if they are scanning, they could miss, if they're scanning left, they could miss something on the right or something like that. He said, this kind of system could monitor and prevent such situations from happening if developed and tested properly. And I'm like, yes, yeah, that's what I want, that kids, adults, sudden riptides or things like that can be monitored, and authorities can be alerted. So it was
Wow.
love to hear from the real person that there is a need for such a system.
Yeah, so you got a good clear validation with somebody that's actually got quite a pivotal experience in
Yeah.
this space. That's absolutely cool, man. It's really cool. Sadly, we haven't had any questions come through since the earlier ones. Vibhu, if anybody wants to contact you and talk to you about that project, how can they get in touch with you?
Well, I'm on LinkedIn. So just search my name over there, Devang's name over there. Send us a question. Because we work on many different technologies, as Devang said, we worked on CVAT as a product to annotate the object. So there's a separate team handling that. But once you reach out to us, we will be able to contact you. And also the blog that we have written on Intel AI team has our contacts over there. So you can go there and then to click a link and we'll help you.
Brilliant. We've got a question from David. Hi, David. David's at Belina. Is any of the code on GitHub as open source?
Yes, so that's also Intel's key aspect of contributing back to the society. The code in Edge Software Hub, the Lambda functions and all these are made open source, so you can use it in your product, in your
Excellent.
thing. The Openvino utility that converts models from benchmarking or like converts a model from Openvino to IR format is also open source, so you can use it freely. OpenVino itself comes with a license, depending on how you're using it. So please read that one.
Awesome. Okay, brilliant. Hey guys, thanks very much for your time. It's been an absolutely fantastic talk and possibly one of the most well-constructed and short shows we've had for a monthly tech meetup, but you've done extraordinarily well with it as well. So brilliant. Really look forward to hearing how this goes on. And thanks very much. We have the usual Thursday, I was going to say a breakfast club. We've changed it in now. It's now food for thought, so I can move the times depending on which location people are joining us on. We've got a professional snooker player and hopefully a professional boxer chatting about mental preparation for winning and dealing with failure. So that's on. It's 8:30 a.m. on Thursday morning. Usual channels. The YouTube channel. Do subscribe and get the notifications. When LinkedIn works, which sometimes it doesn't, like today, then it's on there as well. And obviously the Facebook channel as well. So if you search IoT North UK on Facebook, you'll be able to find us on there. Devang, Vibhu, thanks very much. It's been absolutely fantastic having you on today. Really appreciate you joining. Thanks very much and good night.
Now, I'm not in the habit of taking orders from a machine.